would love to introduce my incredible colleague, Yann Bilien, okay, who is the co-founder and chief scientific officer of Rippletide, okay? So just a quick introduction before we go. So he is going to speak today on automatic ontologies, right? The O word, the big O word. Build the context graph for trustworthy AI agents, where he's going to argue that AI agents don't fail because the model's capabilities specifically, but actually because there's no structured context, right, to ground their decisions. And so I'm going to pass it off. Let's give Yann a big round of applause. Thanks so much, Yann.
Hi everyone, and welcome to this last talk. Thanks for the energy. That's very nice. So I'm Yann, co-founder and chief scientist of Rippletide. We are a 2-year-old company, and we are focused on bringing the right context to the agent anytime, and even more. So we are building a decision infrastructure. And before that, I was doing AI research at Imperial College in London on the limitations of reasoning models, language models, especially for the reasoning. But today, for this talk, we'll go over something else, is how to actually build such context graph. I hope that thanks to the past talks, now that you want to build such a graph, so we'll see how to do so. And to start, I'd like to make a confession, is when we started at Rippletide, onboarding the first customers was actually really, really painful. The point was, we had to build those graphs manually. So we have to build knowledge, processes, everything that was described before manually. And this is kind of a really, really big pain that we had to solve. And so as a researcher, guess what? What did we do is we brought some bright minds and we worked on it. And so we are now 18 months of R&D later and real enterprise deployments. So happy to share how to automate the creation of graphs, and especially through ontologies. So, as luck would have it, I'm the last one to talk, so I won't dig into what is a context graph. I hope you understood that before. Maybe I can just show some real example that we did on production deployments, so that you can see real examples. So here is the first one that is on a coding use case. And you can imagine this one was used as a testing agent. So every time you commit something in your repo, you want to test everything from your repo. So this is kind of small graphs. We can also have much bigger graphs. As you can imagine, as you ingest more and more data, it tends to get bigger. And maybe a third one that is smaller, that is one focused on credits. So it's for a car manufacturer. So how do you provide a credit or not based on the customer you have? So what do we have in such graphs? You have mainly 3 things. You have some knowledge. So that's, I think you know, knowledge graphs, that's kind of a fairly common thing. So that's entities. So I don't know, for example, client, vehicle, or something like that are linked through dependencies, so transitions. So that's point number 1, but it's rather classic. The second thing that changes with context graph for agents is having processes inside the graph. So why do we want to have processes? Is we don't want to let decisions to language models. Otherwise, you will have all the drawbacks of language models that you all know, hallucinations, not following some things that you ask to the model. So you want to have that processing inside the graph so that you can build the automations and the decisions directly into that. And the third thing that we have, maybe we didn't talk about it before, are guardrails. So we can put definitely guardrails into a graph directly. So why not benefit from it? Since if you put guardrails into a graph, you can just forbid some part of the graph so that you can have deterministic roles and not just putting a prompt and then hoping that it will be followed by language models. So basically, we have those 3 elements into our context graphs. So some knowledge, and some guardrails directly living inside this. All right. Maybe I have a question for you for the next part is, how many of you intended or already considered using a context graph project? Just to raise hands. Okay, I'd say 60%, something like that. Okay. And so second question is, how many actually built one and that is running in production? Okay, I'd say maybe 15%. So we'll make the talk at least for the diff of the lowered hands that wanted to do so, but did not finish that. So we're going to see how we can automate this thing. Maybe just to introduce how to build such graphs, you have three main challenges to tackle when creating graph, and that are long-standing challenges for building graphs. The first one is the initial setup. It's always painful to do that manually, and there are some challenges that are tough to solve. Let me give you an example. If you connect to multiple data sources, let's say an ERP, something like that, you have a column that is called revenue, you take a CRM with a column revenue, are we talking about the same revenue? Yeah. So that's something you have to explicit, and AI has a lot of difficulties to do that for you. Second challenge is once you build the graph, you need to represent this graph. And as we've seen before, graphs can be very, very large. And so you have some difficulties to represent those graphs. Maybe I can show you some ways to do that. So this is kind of a large graph. If you zoom a bit, you can have those clusters. And so inside those clusters, you can have all those data. So imagine all the transitions and all the nodes every time you add a new data into that. You can have very, very large things. So I'm going to show you some iterations that we did on how to represent such a graph. As you can see, this is non-usable in production, right? So I can show you all the iterations. All right, sorry for the quality of the videos, but you can have graphs that are in 3D. Actually, there are multiple dimensions. Or even when you add some new data to the sources, it tends to be very, very difficult to represent those graphs. So that are two challenges you have to keep in mind. And maybe the third one is regarding graphs updates. So every time you put a new data into your graph, you want to preserve the coherence. You don't want to break everything. So that's, let's say, the three main challenges that you want to address. And there is a fourth one, actually, is maybe you have it in mind, is once you have this graph, how to use it, for example, for an agent. I guess many of you are building agents. And the common way to do that is through RAG, graph RAG, so many types of retrieval pipelines that always tend to be bottleneck at scale. You can understand if I take the coding example, does RAG work well for code, for example? The answer is no, and so cursor and whatever, they did other methods such as grouping and on other things. So at scale, we always see that those graph RAG things are bottlenecks. I think in one of the previous talk, there was a metric regarding graph RAG. I think it was 81%, something like that. So do you want to have only 4 times out of 5 the right context for your agents, or you risk hallucinations anytime you don't have those things? So graph RAG tends to be very limited. And so on how we developed and how to create those graphs, we try to build something else so that we don't need the graph RAG or whatever pipelines like this. And so I'm going to introduce something that we developed that are graph-based ontologies. So we want to have both a graph structure that you can have and also some ontologies. So maybe you've heard about ontologies. So what is an ontology? It's just giving some meaning about some data. For example, if I come back to my example here, you have some products. This is kind of a marketplace. This was a retail customer. You have these products, so you have some attributes for those products. And so you want every product to have those attributes. And so those ontologies that can be also represented through clusters like this. You can imagine that every node actually has a lot of references into the graph. And so using those ontologies, actually the data and the processes are the same area into the graph. And so you don't need anymore a RAG pipeline to feed your agents. And the key point to keep in mind is what worked before when we talk about graphs, things like that for chatbots, does not work anymore for agents, because now you have multi-steps into your agents. So if you take something that works, 95% of the time, so you have 5% of the time the wrong context. If you have 10 steps that are classic workflows, you'll have a kind of a 40% error rate. So that's too high. So you have to change things and how to build those graphs. Something that we understood since the very beginning is when you build such a graph, you have two methods to evaluate actually how's the graph. I don't know, the customer is asking, is it working? Is it improving my agents? And it's kind of difficult to answer that question. So you have two ways to do that. Either you want to evaluate the coherence of your graph. So for example, if I had a new data, does it break something? What is the coverage of my graph? But if you want to put agents on top of that, for you, the key point is my agent working in a way? And so that is kind of a key building principle, being able to evaluate your agent. And I can show you some example on how you can do that. So as you have some processes into your graph, what you can do is just run the agent and see how it performs on many, many tests. So every time you add a new entity, something new into your graph, you want to test your agent again and to see if it actually improves something, if you have some regressions into your graph. And so along the way, you always evaluate what you're doing along as you keep new data. So if we add this small thing, when we add new data, every time there is a new point, you want to run some tests on the agent in the background to know if the agent is actually improving or not in the end, because what you want is just an agent that is working in the end. Another thing to keep in mind, and I know it's a bit long, you're hungry, so we'll make it quick, is how to manage graph updates. So when you have a new data, how to make sure you have three things to be careful about is, one, you don't want to have incoherent data. You don't want to have contradictory data. So contradictory, that means, for example, you have a documentation that is for the credit, for example, credit agent that I had here. You have a document that says the credit is 4.5%, and you add a new documentation that says 6%. Which one to keep in mind? And if you just provide this context to a language model, it will choose one or the other depending on the times. So what you want to do is actually to explicit those inconsistencies so that you deal with those inconsistencies during the build time of your graph. And so you don't let all those computations during the inference with the risk of having production issues when it's running. So keep in mind that you want to build one time, validate, evaluate that the graph is strong enough, is working, and is improving the agent. And after that, you want determinism, you want predictability for your graph. And so the key message I think that you can keep in mind is there is a big momentum actually regarding context graphs and things like that. And thanks to the Neo4j team for having been worked on that for many years for now. But now we can have the key benefits of context graphs. So key benefits that you know is if you bring the right context to the agent, you have more predictable agents. If you have a graph, everything is explainable. And since you have processes now into your graph, you have end-to-end explainability. That is something key. And at the end, you have predictable things because you have the right context at some time. So you have all the benefits of the graphs, and now you don't have the drawbacks of initial setup or maintenance of the graph, things like that, thanks to new tools. So we can leverage language models for building the graph, but not for the inference, so that you will have stable things in production. So feel free if you have any questions. I can share maybe if it's interesting for you. You can start. We have some things that are open source. If you want to try, for example, an MCP on context graph, feel free directly on docs.rippletide.com. You can directly evaluate your agent at first, so just connect your agent. We have, for example, CLI that are running. Then you can put directly a context graph. So with an MCP, it's really easy to connect. It's a few steps. And in the end, if you want, you can go even into a stronger position with the decision runtime. So you want to have deterministic decisions once it's running. So happy to dig into everything. If you have questions, give it a try if you want. And let's go for the panel. I think I have a QR code if you want to scan everything, if you want to reach out, or if you want to find the documentation. Thank you very much.
Thank you so much. Thank you, Yann. Another round of applause for Yann. Thank you so much, Yann. Woo! Okay, everyone.